All right, everyone. I'm going to go ahead and get things started. Welcome to our weekly API meeting. I know we haven't had it in a few weeks. I've been in and out, and we haven't had volunteers to host the meeting. Just to everyone to be aware, next week is a holiday. So, again, we won't be having the meetings. We'll pick up in about 2 weeks. Then we'll be going for a few weeks, and then I think we're going to have probably the Christmas holidays where everything won't be very active. So we'll probably after that pick up after the new year. So just wanted to put that out there. The topic that we have for today is related to the CNI and the Kubernetes stuff that Intel presented just recently. So Dan, I'm going to let you go ahead and go over what you wanted to cover related to that.
How did the wedding go?
Oh, the wedding went well. That's 2 out of 2. And then of course my my youngest daughter then told us on Sunday after the wedding was Friday for my son, she told us, okay, we have the venue locked down and we have a date. So now there's the setup for next year in November. So
Oh, wow.
so three
Cool.
of my 4 kids will be married.
Wow. That's exciting.
Yeah.
All happened at once.
Yeah.
Just, all right. I am sorry. Too chatty. Actually, I guess I'll go pull it up in Chrome. That makes sense.
That's fine.
All right. Last week was KubeCon. There were a bunch of related talks on KubeCon had they themed the networking track to be telco and edge focused. So they asked people to, if you're talking about networking, please bring a networking and edge networking for edge and telco flavor to it. So I just put it in the title, and we got accepted. And the idea of the talk was to kind of bring in what we've been talking about here, which is we wanted to talk about how in edge and telco, a lot of people have been using Kubernetes like almost across the board, but they use the Kubernetes for sort of like the compute, like provisioning aspect of it, and they bypass the network because the network's too slow. And they want to use SRIOV, they want to run a PMD for their 5G user plane to be able to scale up. And we wanted to talk about how to give different options to maybe do that optimization a little differently. And that's what we've been talking about in the OPI context. So I started out by saying, hey, there's this trade-off between abstraction and having things be super optimized. And so, 5G has always been sort of on the optimization side. But last year at KubeCon, we had this separate talk that was not edge and telco focused, but it was talking about how we would like to offer a Kubernetes network that was higher speed and lower latency, and that the mechanism that you got there is hidden from the user, so that you could be using a DPU, an IPU, optimized software, something like that. And you pick your implementation, pick your vendor, but your applications would not have to change or be affected by that optimization. So we wanted to preserve the abstraction, but just go faster. And then, definitely these edge and telco applications that are network sensitive, they would benefit from that. So we wanted to tie in the work that we've already been doing, the talk through the telco use case, and then talk through the standardization that is needed. And I wanted to bring this in today to be able to answer the question of like, hey, what do we need from OPI? And where does this ultimately land, all this work? And I think that all this work ultimately should land in the CNCF. It should land in Kubernetes somewhere. And that our call to action is effectively saying like, hey, let's just agree on what the right interfaces are, and then let's go and enhance Kubernetes to be able to make this a broadly supported mechanism to do this optimization underneath the abstraction. So I said all of that in a video because I had COVID, so I couldn't go. But Ian started out and talked about first he introduced SRIOV, sort of like for the Kubernetes folks who haven't had to go and break their own abstraction. This is very common in telco where we have to we can't use the Kubernetes network to interconnect things on the user plane. We have to use a physical switch to interconnect things. And then in order to get the traffic to the physical switch, we push the data over these SRIOV interfaces. And then we also, because this traffic is not terminating TCP or anything like that, we use a pull mode driver like DPDK to move data really quickly. And what happens is that these very specific hardware NIC details start leaking into Kubernetes, and it's kind of a mess where what used to be cloud native and easily scaled out and sort of nicely abstracted is no longer cloud native. You're not native to a cloud. Now you're native to a specific NIC or specific deployment, depending on how that's all kind of like cobbled together. And so because these are separate, you have to have your own network policy. And I think maybe in the voiceover, he said that you have to have your own network policy, you have to have your own load balancing, and you have to have your own switch, the switch router, so you have this expensive router and this is what the EVPN project is getting to in OPI, is that you have this expensive router that needs to be programmed. And now you have broken that out into the separate from Kubernetes itself. There's also a couple other pain points about having to drain the network when you're doing a reconfig and having to do all this SRIOV enabling that is kind of a mess. And it flies into the it breaks this idea of being able to write fungible applications. That was his term, is to say, hey, I want to run an application. I want it to run in the cloud or in the central DC or in some of these farther out places, and just write it once and run it anywhere and not have it have any specificity in terms of, oh, well, I know I'm running this thing and it's going to sit right beside a particular vendor's router. So, and I know I'm going to have to go configure that router, and I'm going to have to go configure the SRIOV in the platform. And it ends up that your applications on the right are written in a totally different way than your applications on the left. And so we want to have that fungibility to be cloud native in the edge. so that was Ian's section. And then, oh yeah, here we go. Sorry. So we want to be deployed anywhere and easily. We want to have minimal coupling, and we want to be able to burst into the public cloud. And then I think he puts in the session before, Google presented on the multi-network Kubernetes enhancement, which is the same thing that we're asking for. And the multi-network Kubernetes enhancement is, if folks are familiar with Multus, Multus was a Intel project that was made to allow pods to have multiple interfaces. And so the multi-network is trying to make that a first-class citizen in Kubernetes, so that you can it can be used for SRIOV, but it also is really useful to be able to have just a regular networking interface for your pod, and then have a separate network interface for your user plane network over for 5G. So that was Ian's section, and then Nabil from Bloomberg was going to, he presented on the benefits of DPUs and IPUs, the benefits of having these types of devices in a system, and he gave a bunch of examples, some different solutions, and then he went through kind of why you want to offload and why this is important for telco and edge. But you have the capability of being able to either save cores on the CPU or increase the total amount of capability on a platform using the offload, or both. So that he went through a little bit of that, talked about the target architecture. We get into more details about this later, but this is sort of an agent-based architecture. And so this is getting into the two Kubernetes enhancements that we want to get to. Ian talked about multi-network, and Nabil is kind of alluding to this agent model that we have, where the host CPU is still running Kubernetes, but you have some agent running in the DPU IPU to be able to accelerate it through some API. They did just this using Calico. So they use Calico to accelerate Kubernetes using a DPU. And you can see that, Calico and Kubernetes stayed on the host there, but they used the Calico data plane API to offload the functionality of routing and load balancing, and this ran P tables on the DPU itself. So they just moved all the P table work off of the host and onto the DPU. And then they talked about the experiment that they had and the data. He's going to do the video is going to come out next week from KubeCon, but essentially the data here showed that roughly a 2x improvement in performance, during this DDoS attack test case that they had. They also did just had some observations about, I think this is all well known in this group, and then he had some data on encryption to be able to show the value of doing encryption in a DPU using KTLS. And yeah, the KTLS offload data is pretty impressive. Same thing here. I'm going to go a little faster because I'm going too slow. So DPUs and IPUs give you security, they give you trust, they give you performance. You can move the control plane, over time, and you can program the policy, and then, programming the policy doesn't cause your performance to go sideways. because it's being done on hardware. And then Vipin couldn't make it for KubeCon, so but we spoke to the standardization, the needs for standardization in his section, and we talked about OPI, talked about these different gRPCs, and we talked about P4TC, which is a project that we've brought into OPI here, which is trying to make a P4 first class citizen within the kernel. So we touched on that a little bit. And then Nooper, who's on the line, talked about where we want to go. And we talked about KEP multi-network, and we talked about IPDK as a working example. So KEP multi-network is literally just trying to get Multus into Kubernetes proper. There's a great document listed here from in the slides. Go into dirty details, and then IPDK is just a working example. It works the same way that that Nabil showed, where we're using the Calico data plane API to have an agent model, where when a new route or new endpoint is detected, that instead of pushing that into ptables or eBPF or whatever, they push that in through the data plane API. That gets picked up by the agent in the host and then is shipped to the manager underneath. And then instead of programming some sort of software data plane, we program the IPU, DPU, IPU, whatever DPDK pipeline, depending on what you're running, what target you're using in IPDK. So as a result, I think we're making really good progress on getting this up into Kubernetes, so it's a lot easier to use. And the Kubernetes recipe, its next release is in January. We have a lot of this functionality working. We still have an open on how to, when you are using SRIOV with a Kubernetes network, the draining problem still exists. Maybe it's less bad, so that's still an open. But otherwise, we've made a lot of progress on being able to replace the router that you would use in a telco environment, replace that with a Kubernetes network, and have that Kubernetes network be high performance, and also to be able to support crypto underneath that, where if you're going, that picture where you're going from left to right, where you're in a different sort of column in the deployment, all of that is secured with IPsec. So you'd want that to be able to run together with your Kubernetes offload. So I think I'm gonna hang out on this slide here. Is that what we want to see in terms of standardization, and I think that it may make a lot of sense to start it here inside of OPI, because of the work we've already done on EVPN and things like that, is to be able to standardize on how do we support multi-network pods, and how do we support CNIs with this agent model. So the only CNI today that supports this agent model is the Calico. And something that potentially we could do here in OPI is to say, hey, we think that the right model is for us to not change the CNI, like make a customer use a specific OPI CNI or whatnot for a DPU IPU, but that we would go and add the DPU IPU functionality into existing popular CNIs. And so we would want to go and add this functionality to the OpenShift, the oven, CNI, Cilium, and I think we could discuss what's the best way to do that. But I think that Calico, is a really great starting point. They had to have a data plane API for their own architecture when they switched from, I think they switched from ptables to eBPF, but then they made it generic so that they could have a VPP data plane. And we're able to use that on a couple different DPUs now, DPU IPUs, and it's pretty complete, I guess. And that's what we have up in the GitHub for IPDK is an infra agent and infra manager. That's the agent is listening to the data plane API and configuring the backend implementation based on that.
So Dan, is there an API definition that we need to put into the OPI Kubernetes location that would start to fill this out?
Yes, that's what I think. That would be the best thing is if we like if for example, like if IPDK could instead of going from the Calico data plane API to our own kind of gRPC, if we could go from the Calico data plane API to an OPI gRPC, that would be super generic. It'd be like add a route, or add pod, right? Add service. It would be really generic and not specific to any implementation. That would be fantastic. And then we could take that OPI, whatever CNI data plane API, and take it to other CNI implementations, so that they're not going and adopting something that any particular solution has, but it's an OPI solution that they could use. So I feel like that would be super powerful, and something that we could go in and define.
Okay. Yeah, because we have a folder for it, but there's been no contributions to it so far, so I was bringing that up. I think it's the right place to put it.
Cool, that's perfect. Okay. And then I think that long term, all of this kind of lands in the CNCF. But if we're talking about hey, what are the changes that go into the CNIs, then that change lands in the CNI, and it would be better if those changes were an OPI API than something else, or going and telling Cilium that they should go implement this Calico data plane API would be really bad. So I think it'd be better if we could come up with something here in OPI, and so we'd make these Kubernetes changes on the left, and then in each relevant CNI we would push an OPI API that we'd work with them to get implemented. So so that's kind of what we're looking for, is to try to get this Kubernetes infrastructure stuff implemented in CNCF on the left, and then work with the different CNI vendors to get hopefully an OPI API landed inside of their implementation. So that was the color. I think it was well received, even though I wasn't there because I had COVID. But when we presented this last year, it was kind of like it was like, hey, now for something totally different. Let's talk about hardware. And it was at the last session of the last day, and the focus in the CNCF has really shifted. We're just saying, wow, there are a lot of people that are this is a real problem that needs to be solved in Kubernetes. So they pushed us and the multi-network session, right after the keynotes, and started early to talk about this, and this could be a great way for us to integrate these types of devices into Kubernetes in a really natural way, so that we're not pushing the attendees at KubeCon to go and change their stuff. We would really be pushing the Kubernetes sort of enhancement team to add these couple features, and we'd be working with the different CNI vendors to adopt OPI, which would be kind of cool.
Okay, great. Questions from anyone? I saw a few people go off mute, but we didn't get any other questions.
Yeah, I guess
Yeah, sorry, I have a question. So like it's been a while since I followed the multi-net work in the KEP, at least in the SIG, but if I recall correctly, like it's all about getting multiple networks recognized as first-class citizens in Kubernetes, rather than just having this model where only having one primary networking interface is the networking model for Kubernetes, right? So like, are you saying like throughout this presentation that the focus here is completely on the secondary or beyond secondary interfaces? Or like I don't understand how this is kind of relating to offloading primary networking in Kubernetes.
Yeah, I think that when we've been working with the application vendors, the overwhelming preference is to say, hey, I kind of want to keep my secondary network the way it is. I like that my user plane is separate from my primary network. But I'd like to keep that secondary network, potentially even keep the SRIOV in that secondary network, but the networking for that secondary network would be done in Kubernetes. So that's almost like their step one. It's like, hey, that's the easiest thing for me to do. And then if over time I wanted to re-architect my application to just have not use SRIOV, not even have a secondary network, I could do that because Kubernetes now can support the networking at full rate. But it is kind of nice to have it separated. If you have some sort of control traffic that needs to get into the pod, that doesn't get interleaved with your user plane traffic.
So just to add to that, then there's another reason why this is very important, right? On the edge side, from the 3GPP spec perspective, all these interfaces, different interfaces have been defined. Now, some of these interfaces need a notion of service on top of them. They need policies to be applied on top of them. Just because it cannot be done in a centralized way from Kubernetes today on these secondary interfaces, the main reason for having Kubernetes understand all these interfaces is to bring a common functionality through Kubernetes on all these various different interfaces. So that's the main reason why KEP is now seriously considering enhancements for secondary interfaces. The second reason why we have this agent model is because of the chained CNIs. So the reason they are talking about a use case for this agent model is because when you have multiple chain CNIs for different functionalities, you have certain policies defined in terms of, like, say, RBAC, or in terms of something strictly in terms of how the CNI should work. And when you're chained, you break that functionality over a period of time. You can't pass the same policy from one to another in chain manner. So they are approaching it from 2 points. They're saying, okay, you have an agent model which actually is aware of different objects in Kubernetes, either through using kubeclient, watching these objects come and go, and you can enforce a common policy across. all of them. So that's another reason.
Yeah, that makes sense. It's nice. In VMs we have VMs with multiple networks, and it's nice. It's a nice feature. So, but yeah, I would say that our goal, we started out by saying, hey, why don't we just accelerate the primary network of Kubernetes? And
Yeah,
that's
no,
what
I
we
understand what you're
did.
saying then, Dan, but like
Yeah.
I'm struggling to see from a networking point of view where the value add is there versus like we're basically saying, okay, we want to accelerate secondary networking plus, grand, no problem, I'm on board. Where's the value add versus having, SROV on a directly accessed from a NIC? Like you're adding a layer of complexity to manage a DPU, to offload networking to accelerate it, but all you're offering is an accelerated VF.
Oh yeah, no, there's two big pieces of value here. So if all you do is move the secondary network out of the physical network and into Kubernetes, then you're offloading that switch router, and you're removing the switch router from the cluster, and that's a pretty big benefit. That could be,
Well, offloading the switch router is outside the context of Kubernetes because that resides in your server rack. The switch is sitting at the top of your server rack doing your secondary networking piece. I'm like what I'm asking here is we're introducing a level of complexity, right? Which is a DPU, which we need to manage because we're offering accelerated VFs to the pods that need them, whether they're telco, edge, whatever it is, right?
Yeah.
But like at the end of the day, it's rather complex and it's a rather big ask to ask a customer to transfer to managing and using a DPU when they can just use a VF off a NIC directly with the secondary model that exists today. No?
So there are limitations. Let me answer that, right? Today, when we use Multus to create these VS, which is nothing, just VS, right? With MAC VLAN or whatever way you want to do it.
Sure.
You cannot enable a couple of features that are inherent to Kubernetes. You cannot have that use DRA. You can't have that use service load balancing. You can't have it working with the network policies that Kubernetes supports, right? You cannot have any of these applied to your secondary interfaces as such, because these Kubernetes doesn't understand what these secondary interfaces are and how to handle them.
I mean, they're managed like a separate network.
Yeah,
completely.
So now for CUDU use cases or for UPF use cases, the service notion comes not on your primary, but it comes on your secondary interfaces too, because you're connecting microservices using your secondary interface. So that's the reason this whole multi-network effort in Kubernetes started, considering all the edge deployment use cases where 3GPP specs enforce that you use these performant interfaces, which are today's Multus secondary interfaces, for service use cases, for service scaling, DRA, those kinds of use cases. And that's the reason we are kind of making all these secondary interfaces first-class citizens as KEP project. And from OPI perspective, these would be under the umbrella of vendor, how they want to expose these all interfaces in a unified way. So there's no difference between what is primary, what is secondary, what is my multiple secondary interfaces. I apply uniform policies across all. I apply uniform service notion across all.
Yeah, no, I kind of get what you're saying. I guess I just would have assumed that those things will be applied at a Kubernetes level, and they wouldn't really care if the VF had a DPU sitting under it or if the VF was from a NIC. You know?
They would not care. That is true. I agree with that statement. Those Kubernetes doesn't care, and frankly, from cloud native perspective, they should not care, right? So this is a functionality of OPI how we are exposing our interfaces in such a way that it's still cloud agnostic, and we enhance it through our own API. Because as a vendor, we do understand if it's a DPDK based interface, it has to be bound to a certain driver. If it is a simple SRIOV interface, or it's a sub function, how it is being exposed out, right? And what hardware functions do we need to call on them to either create them, manage them, or allocate resources for them? So there's a separation in terms of functionality. What Kubernetes, which is cloud native with secondary interface support, can do, and what OPI as a vendor centric SDK can do.
One input I have is like there is some work going on the Multus service also. So the networking plumbing group is trying to provide services for the secondary interfaces.
Right,
And
I
think
am aware. Yeah, I'm aware of that. So there's a timeline issue here, right? KP usually takes around 1 to 2 years to be fully mature, right? And in meanwhile, people who need it are looking at Multus to enhance it, right? But these are two separate processes going on in parallel based on timeline. And I fully understand why people are enhancing Multus today, because if they can't wait for 2 years, or they need to have something right away, they have to look at existing solutions.
yeah, it's definitely in early stages, and there's a lot of work to be done. But I think the problem is like, despite DPU being there or not there, people do need these concepts of Kubernetes on secondary interfaces, even on general purpose servers, not necessarily having DPUs.
Yeah, I think that's an important part of the abstraction, is that if you just went with the left-hand thing, right? And you said, all right, I want to have multi-network pods, and I want to have a CNI with an agent model, then, I could do this with optimized software. I could do this with VPP and get a ton of value out of it, and be able to move the networking out of the router, which is I wouldn't say that is outside of Kubernetes, because that's a big cost. That's a big complexity thing that you could go and solve that problem with this agent model in the CNIs. And then once you had that, then you could start to think about writing or making changes to your application so that it is more cloud native, and that now it's not, whether it's using SRIOV or not, or using DPDK or not, you could start to write it so that, it could run in the cloud, because you're no longer depending on that attached switch router. So you could do the left-hand side just in Kubernetes enhancements, with all in software, but you would need this agent model to be able to speed up the data plane, for it to satisfy the requirements of your application. And then the DPU IPU is almost like a bonus. It's like, okay, well, if your platform has one of those things, then you're not using optimized software anymore. You're using super fast hardware. And I think we want to lead with software with the CNI vendors, right? It's to say, we could have to use a DPU IPU here. This is just a path for even the software vendors to go and offer much more performant software implementation. Just like that picture that Nabil had. He ended up just moving the P tables to a different place. You could have just as easily kept those P tables on the host, be able to optimize it potentially in a different way because it's in a different place.
Okay, any other questions? think the key thing that we need to start thinking about collectively is how do we start building out the API that we're looking at, what would be OPI XPU type of API that we could put into the Kubernetes area of networking. So that's something to consider and see how we can start contributing to that. Other than that,
As a straw man
Okay.
proposal,
Mhm.
what do y'all think about kind of similar to what we did with security, where we made a like a 1-for-1 gRPC mapping between the Strong Swan VC interface and our OPI security gRPC. What if we did the same thing, but just sort of in reverse, where we took the Calico data plane API and just mapped that 1-for-1 into a OPI Kubernetes data plane API, and that would call into an agent, either an agent or a manager. It depends on how we want to architect it. That would be more standard. And that's something that we could go and adopt in IPDK. That would help us out a lot, standardize that whole interface. Is that worth us proposing and investing in?
Is it a 1-for-1 or do we need to map it to the CRUD model?
Yeah, I would say 1-for-1, asterisk mapped to the CRUD model, just like we did with just following the same way or following our same intentions for the security API.
Yeah, the security API still has to map to CRUD model. It's not quite there yet. It's
Yeah, I
still
agree.
got a lot of pieces that are very, very specific to Strong Swan. And we need to remap that one into CRUD model. So yeah, if we consider it as a straw man to map to CRUD model, then I think, from my perspective, it's okay, but I'm not the only vote that's here within the group.
Not make the same mistake. Yeah.
I mean, it's a starting point, but is it really representative of the CNIs and Kubernetes? Probably not. You probably need to pick more than one.
Yeah. Just since no other CNI has a data plane API, we figured that's where we'd start. But
well, I would argue all the CNIs using Linux have a data plane API. Their API is the kernel. So,
I know the kernel is like an
know.
enigma wrapped in a whatever. I forget the cliche. Yeah.
Not for kernel developers. It's not done.
No, but you know what I mean. It's there's just so many different ways that you can do it, and it's sort of chutes and ladders, like as opposed to like trying to map that to a CRUD model is pretty hard. But like if I can say, hey, here's a new endpoint, here's a new service that those functions potentially don't have a natural, or maybe they do. So maybe if we did make this API, we could, as a second step, say, oh, let's go map this to the semantics of the kernel and see how far off we are. That would be interesting.
I would be much more comfortable, I'll be honest with you, starting with the kernel, because a lot more CNIs use it. But I get where you're coming from. I understand where you're coming from.
Yeah,
so I don't know the Calico data plane abstraction, but I'd be interested to know how far away it is from the what a pod needs. In other words, what Kubernetes concepts are applied to networking, because obviously that is L3 IP addresses and subnet ranges, it's service policy definitions, it's things like that. So I'd be interested to know how far away from that the Calico data plane API is. And because that Calico data plane is going to be somewhere between that and kernel networking, and I want to try and figure out what the right level of abstraction is.
Yeah, if I figure out the mute button. Yes, exactly. Yeah. So and that's why I'm trying to dial up the Calico has a really good picture, if I could find it, on how it works. But yeah, I think that when I look at it, it makes sense from a Kubernetes standpoint. I don't know how well that that maps to the kernel. So, but we can answer that question. I mean that might be. Oh, here we go. Here we go. Yeah, this is the picture I wanted. Let me share this. Share. Come on.
Can you share it in the Slack channel as well, please?
Yeah, I'll put the link in the chat.
Thank you.
Wait, doesn't it come up? Oh, I always press the wrong button here. Here it is. So here's the here's how the data plane ends up working, right? Is that you have these direct connections to the pods, and this is why we need, is the few things that we need to offload is just to have a direct connection into the pod. Obviously, we want multi-network so we can have multiple connections into the pod, and then the all of the same configurations that happened in the host for Calico, whether it's BGP or Kubelet or Felix or whatever, for policy, is the data plane API is this little line there, and then you can see going up a little bit the types of things that get so they have this. And the same sort of manager model where agent manager model where you have if Kubernetes comes and sets up the services load balancing, the agent grabs that and sends it to the manager over the socket. If Felix comes in, does a policy, that gets snagged by the agent, sent over the socket to the manager. BGP, and then when a CNI, when a new interface gets connected, you get information on that. So these four things at the left are kind of the macro sets of functionality that are all sort of regular parts of, in this case, Calico, but they're regular parts of Kubernetes that get kind of laundered through to this data plane API on the left. But I'll send this information. I'll drop this in the chat. And I'll drop the information on the KubeCon presentation. I'll put the I put the slides in the Slack already, but I'll put the link with the I better do that now. Put the link that will have they'll have the presentation in the chat too.
Or you can put it on the Slack channel, Dan.
Yeah, I'll put it on the Slack channel. Yeah. I'll put this thing in the. I'll put all this information in the chat Slack channel.
Great.
Yeah, no, just regarding, the level of API, I get what you're saying. It's just, like this is what I would consider a very high level API. And for me, it's for CNIs that are willing to rewrite or implement new functionality as part of their core offering. And I think if we look at something like the kernel APIs, it's probably for existing CNIs that don't necessarily want to change what they're doing, but still be able to take advantage of DPU offload, And then the question is like, really, is OPI going to offer one of these, multiple of these, you know, as in a layered API, or is it something else? And I'm just missing. You know,
is there like a kernel API that will tell me like, oh, CNI add, right? Is there an equivalent? We're starting from the top there. It's like the simplest is that I've added a new interface or a new
yeah, well, CNI add is where the CNI will actually take the NetDev from the host networking namespace and just move it to the pod networking namespace after applying IPAM or something else. So of course there's kernel utilities that let you do that. I mean, the most basic CNIs are written in Bash, and they let you do that, right? So I've seen them.
But you could
yeah.
when you do that, you could also invoke this OPI API that says CNI add, and then the agent could talk to the data plane to say, oh, that to this new CNI. I mean, you
Yeah.
even have to add in the CNI to the data plane of the accelerated whatever. So, but
Sure. No, I understand. And again, like it just comes to levels of APIs and where we want to get to. And I guess there's no reason to block a high level API from being defined. You know, I certainly wouldn't do that. But the point I'm making is if we're looking at kernel level stuff, it's probably a lower layer API for offload, I imagine. And I don't know if anybody wants to agree or disagree, but you know, feel free to jump in.
no, but this is a good direction, is we can define the high level API and then let's decompose it into what the kernel is understanding.
Then we may have to drive out multiples anyway from this.
True. That's right. Yeah, maybe something is too high level, but you know, I think, you know, Kubernetes policy API, you know, that's sort of already defined. So that flow just like feels like it already has to exist, right? It's just there's just a couple different kernel implementations, like eBPF or ptables or whatever. But yeah, so it's just another one.
I think the kernel API is a good start, but it's probably challenging. For the load balancing or policy programming, it basically uses the IP tables. So there is an API to program the IP tables, but IP table programming is like a programming language. So you can come up with all kinds of chaining to the IP tables, and that's how it is currently programming for load balancing and the policies. So it's not as clear as the create policy or things like that. You come up with all kinds of chaining to achieve the policy management.
That makes sense. Gotta start somewhere though. I'm gonna stop sharing because I can't tell what I'm sharing. And I'm pretty sure I'm not doing it right. All right, I'll send these details out, and yeah, I think that's our proposal. I don't want to embark on it if people don't think it's a good idea. But we're happy to
start.
Yeah, happy to offer it, and would love to switch out from you know, just using Calico only to something that's OPI based.
Yeah. Okay, great. Well, thank you, Dan. And yep, I think we should go ahead and start at that point, and then we'll just continue to flush it out from there, get comments, reviews, etc.
All right, great, thank you. I'll post it on
Great,
the chat
right.
on Slack.
Thanks, everyone.
Thank you. Bye.
And I will go ahead and close out the call. Get a couple minutes back to get to your next meetings, I'm sure. Thanks, everyone, for joining.